Okay, Chapter 7, Section 4, problem number 13. As you can see here, the administration at a college wishes to estimate to within 2 percentage points the proportion of all its entering freshmen who graduate within 4 years with 90% confidence. Estimate the minimum sample size required. So right off the bat, we have to within 2 percentage points. So we have the error plus or minus 0.02 as the 2% within 2 percentage points. All freshmen. So we're looking at a confidence interval of 90%. So alpha equals 0.10. And we'll be needing alpha over 2 here in a moment, I'm sure. So 0.05. So estimate the minimum sample size required. So we're looking to find n. And to get n, we're going to need the proportion. We don't have the proportion that we're looking at here. So for worst case, as we talked about in the book, the portion we're going to use is 0.5 because that gives us the worst case or the largest number of n that we're going to need to be able to get the confidence interval to within the error, the 2 percentage points that we're talking about here. Okay, so our formula for n, then we have n is z, the standard normal variable at alpha over 2 squared, times p hat times 1 minus p hat, or q, over the error squared, which in our case, we have z at the 0.05. See, I was right getting the alpha over 2 there. And in our case, we're using the variable for the proportion p hat for 0.05 as the worst case, the 0.05 times 1 minus 0.5, which is 0.5. I may have said 0.05 there, sorry. Over 0.02, which is our... Ooh, wait a minute. We don't have that yet. Yeah, we do. That's e. Ugh. E squared. I was trying to be looking for the standard deviation, and there's no standard deviation in this one. So let's see. We need z at 0.5. So z at 0.05. Again, this is one of those we can look up in the cumulative standard normal table and find the value that way, or we can use the t distribution at degrees of freedom infinite. And I went and found it that way. So this is 1.645. And we've got that. So we have 1.645 squared times essentially 0.5 squared over 0.02 squared, which is 1691.2. And since we can't have partial decimal sample sizes, we need to round that up. So 1692. So n equals 1692. There is our sample size to have a 90% confidence to within 2 percentage points to understanding the proportion of all entering freshmen who graduate within 4 years.